The nth term of a sequence an is given by n over n squared plus 1. If we have to write its first three terms. So let's begin. Now all we have to do is substitute the value of n with 1 to obtain the first term. So we will have a1 will be equals to, since we have n, in place of n we have 1, divided by n squared will become 1 squared plus 1. So this will be simply equals to 1 over 2. So this is going to be the first term of the sequence. Then we'll go to find out the second term. For that, all we have to do is substitute the value of n with 2. We'll get a2 will be equals to, so we have 2 divided by 2 squared plus 1. So this will be simply equals to 2 divided by, so 2 squared is 4, 4 plus 1 will be 5. So 2 over 5, so this is going to be the second term. And the third term of the sequence, to find it out, we have to use n equals to 3. So this was going to give us a3 equals to 3 divided by 3 squared plus 1, which will be equals to 3 divided by, so 3 squared is 9, 9 plus 1 is going to be 10. So we have 3 over 10, so this is going to be the third term. So that means the three numbers in the sequence, which is represented by an, this is going to be half, 2/5, and 3/10. So these are the three numbers in the sequence. This time the nth sequence is given by n squared minus n plus 1. We can also refer it to as the general nth order term. Fine. So to first out the first term, so here we have to find out the first 5 terms. For the first term, we'll place n with 2. So this is going to give us a1 equals to 1 squared minus 1 plus 1. The negative 1 and positive 1 goes away. So this is going to give us the first term. Then to find out the second term of the sequence, we'll place n equals to 2. We have a2 equals to 2 squared minus 2 plus 1. So 2 squared is 4. 4 minus 2 will be positive 2. 2 plus 1 will give us 3. Then we have n equals to 3. This is going to give us the third term. So we'll have a3, which will be equals to 3 squared minus 3 plus 1. So 3 squared is 9. 9 minus 3 will be 6. So 6 plus 1 will be 7. So this will be the third term. The fourth term will be n equals to 4. That's going to give us a4 equals to, we have 4 squared minus 4 plus 1. So we have 16. 16 minus 4 will be 12. And 12 plus 1 will be 13. So this is our fourth term. And the fifth term of the sequence is going to be n equals to 5. So we have a5 equals to 5 squared minus 5 plus 1. So 5 squared is 25. 25 minus 5 will be 20. 20 plus 1 will be 21. So these are the first 5 terms of the sequence of an, which is given by n squared minus n plus 1. That means the given sequence will be, let's write it down. So the given sequence will be the first term, which is 1, followed by 3, then we have 7, 13, and finally 21. So these are the first 5 terms of the given sequence. Now in this problem, we are given the nth term of the sequence, n cubed minus 6n squared plus 11n minus 6. We need to show that the first 3 terms of the sequences are 0 and the rest of the terms are positive. So let's do that. So what we'll do here, we'll start at our given sequence. So our given sequence is n cubed minus 6n squared plus 11n minus 6. Now what we can do, we can factorize this particular cubic polynomial, and this is going to give us n minus 1 times n minus 2 times n minus 3. So that means we have our an given in its factor form. So let this be number 1. Now our first term will be for n equals to 1. So that means a1 value will be, so here we have 1 minus 1 multiplied to 1 minus 2 times 1 minus 3. So here 1 minus 1, that's 0. That means the entire expression is going to be equals to 0. Fine. The second term will be n equals to 2. So here we have a2 equals to 2 minus 1 multiplied to 2 minus 2 multiplied to 2 minus 3. Here 2 minus 2, this is 0. That means the entire expression is going to be equals to 0. Our third term in the sequence will be n equals to 3. So that means we have a3. That will be equals to 3 minus 1 times 3 minus 2 multiplied to 3 minus 3. This is also going to be equals to 0 because 3 minus 3 is 0. So hence we have showed that the first three terms of the sequences are 0, and when we find out the rest of the terms, so let's say when we look for let's compute n equals to 4, then a4 will be simply equals to 4 minus 1 4 minus 2 times 4 minus 3. So this is going to be a positive value because 4 minus 1 is 3 multiplied to 4 minus 2, which is 2, and 4 minus 3 is 1. So this is going to give us 6, which is a positive value. And we know that n minus 1 multiplied to n minus 2 multiplied to n minus 3, the product of these three numbers are always going to be greater than 0. That means they're going to be a positive number for all values of n greater than or equals to 4. For all n greater than or equals to 4. So that means we have successfully showed that the rest of the terms are going to be positive.